This is AP Calculus AB. We're on self-check 10.1. So we're looking at this graph. We need to find g of 2. So g of x is defined by this integral. That means if I have g of 2, I'm plugging in 2 for x. So it's going to be the integral between -2 and now x is 2 of f of t dt. And again, integral just means find the area under the curve. Find the area between -2 and 2. So between here and here. So if I separate this into different regions, I have a rectangle. So this rectangle is 1, 2, 3, 4 by 1. So it has an area of 4. And then I have the semicircle up here. This circle has a radius of 2, and our equation again is pi r squared. And since it's a semicircle, it's going to be divided by 2 at the very end. So I guess if this was the formula for a semicircle, it would be divided by 2. So radius here is 2, so it's going to be 2 squared, which is 4. 4 divided by 2 is 2, so it's going to be 2 pi for the semicircle. So if I add up 4 and 2 pi, I'm left with 4 plus 2 pi. That is g of 2.
So, Mistress Anilla, what I ended up doing was I did f of t, the line, to -2, and then I plugged f of 2 minus f of -2. So I got 1 minus 1, which equals 0. Is that totally wrong?
That is totally wrong, yes.
What? Like, how come you can't do that?
Because you were thinking table, I think.
Table?
We're given a graph here.
And you can't do that?
You cannot do that, no. Because integral, the literal definition of integral is it's find the sum of the areas between the curve and the x-axis.
Okay.
Yeah, Joy.
Okay, so is there a start of 1 since it begins at -2?
Can I have a bite of the cheese? I'll give you one.
So the height of 1, the height of 1 comes from this 4. So there's no initial condition. If this g of x instead was g of x is equal to, I don't know, 3 plus the integral from -2 to x of f of t dt, then we'd have an initial condition of 3, but there is no initial. The initial here is 0.
Okay.
Yeah, Rosalie.
Yeah, so I did start plus change, and I thought the start was -2, so do you have to add that on at all, or no?
No, -2, there's no start. Again, as I was just saying to Joy, the start would have been right before the integral, and the start here is 0.
Is that 4t 2 pi or 4 plus?
4 plus, yeah. All right, on to part B. So we need to find an equation for the line tangent to the graph at x equals 2. Line tangent, we know what form this is going to be. This is going to be y minus something is equal to the something times x minus something. All right, we know what goes in here. What goes in this box? 2, because that's our value. What's going to go in this box?
F of g of g prime of 2.
G prime of 2, perfect. The slope of g at 2. And then what goes in this box?
G of 2.
G of 2. Perfect. We need to find all 3 of these values. Well, we already found that value. That's 2. Okay, let's find g of 2. Oh, we just did that in part A. Part A said that that is 4 plus 2 pi.
Except I had 0, so I got this one wrong.
Yep. All right. And then we need g prime of 2. So we need to find g prime of x. G prime of x is what?
F of x.
Is f of x. Perfect. Using 10.2 notes. And then from here, we can say g prime of 2 is going to be f of 2. F of 2 means the height at 2. The height at 2, if I come over here, the height of 2 is 1.
Oh no.
So I can put a 1 there. And I'm done with one exception. If I rewrote this equation, I would make sure that I had parentheses around that 4 minus 2 pi. Otherwise, you'd be writing y minus 4 plus 2 pi. It should be y minus 4 minus 2 pi, or just leave the parentheses.
Minus 2 pi?
Because that negative is going to be distributed. But what's better is just leave parentheses and don't touch it.
Okay.
Questions up through B?
Good.
Good. All right.
So I got it, but I just couldn't remember how to do the g prime of x. But I get it.
Okay. Here's how to answer this question in about one line. Are you ready? At x equals -3. Because g prime
You got it.
was positive and it goes to a g prime that's negative.
So we just have to look at the graph for that one?
Wait, I think this is wrong also.
Oh.
Because I'm looking because it's not a positive to a negative, it's a negative to a positive, right?
Yeah. Yes.
So I need to say positive, negative to a positive instead of positive to a negative. So I just need
That's all
to.
we have to do?
Yes, that's all you have to do.
Wait, so you find all the CVs and you just look and be like, well, which one, or also the ending points, and you just look at one and see, okay, which one's literally a minimum. Like, wait, can we have a big eraser?
Yeah, because it's asking you for which G of X
My
is in a relative minimum, so you look G prime of X sign change. That means F of X sign change. So then, here.
Well, thank you.
So I'm literally.
Sophia, are you an outfielder?
No. I'm a cheerleader.
Are you gonna erase it?
No, I'm just going to cross it out. I'm doing.
I'm just erasing the answer.
All right, so once again, let me make this as clear as possible. So if it's asking for relative minimum, not absolute. Absolute, you have to make a table. I thought we were doing absolute, and that's kind of why I started misleading us. A relative minimum, all relative minimum occur wherever you have G prime going from a negative to a positive. So G prime, negative to a positive, that's all relative minimum. Relative minimum. And G prime is the same thing as F. So it's asking where is the height going from a negative to a positive. The height is going from a negative to a positive only at -3.
Yeah.
Yeah. Alright.
We're good?
Wait, can you show me your definition again, really quick?
My definition, there's two definitions. This is the first definition, this is the second definition.
Oh.
Either one is fine, but this is the only one that's accepted on the test and the AP exam.
Wait, Mr. Sindel, I had to erase.
Okay. I'll go ahead and stop the video now. Yeah, go for it.
Okay. So, why is it different on absolute? It's because he told me to do it for the video and you just why is it different on absolute?
Yeah, so the question again is, why is relative different than absolute, right? Why can't we just do this for absolute? Is that the question, or is...
Yeah, because like I thought the only difference between relative and absolute is like where the graph.
So say I have a graph that looks like this. The definition of a relative minimum is wherever I go from a negative to a positive. So that's a relative minimum, that's a maximum. This is a relative minimum, that's a maximum, that's a relative minimum. We don't know which of these relative minimum is the absolute minimum. God dang it. Sorry. So you have a graph that looks like this. This is a relative minimum, this is a relative maximum, this is a relative minimum, this is a relative maximum, this is a relative minimum. We don't know which of these three relative minimum are the absolute minimum. So to do that, we have to make a table that includes all these, including the endpoints.
Oh, I get it. So like you're testing all of them, and then
Yeah.
you see, but aren't they the same?
They might, well, for this one, they look about the same. But what if this one came all the way down here, something like that, where it unbalanced the function?
Okay, I get it.
Yeah, good question. All right, moving on to self-check 10.2. All right, so we have just finding G of 3. So G of 3 means I'm plugging in 3, so let's write that out. G of 3 is going to be the integral between 0 and 3 of f of t dt. And eventually we're going to need to find all of the area of each of these segments. So we might as well just do that now. So this is a circle with a radius of 2 because it comes out to 2. So it's going to be pi r squared. R is 2, so it's 4 pi, but this is half of 4 pi. So all of this area is now going to be 2 pi. So 2 pi for that entire semicircle. I guess that means the right half is pi, left half is also pi. That area down here of this triangle is going to be, it's a 2 by 1, and then times the half, so it's going to be -1. And then this triangle right here is going to be 0.5. 0.5. We'll just find those all right now. All right, we need to find all values where we have a relative maximum. Again, relative maximum is based off of our definition last time.
You're not going to solve for A?
Oh, whoops. I guess I should do that before I go on to part B. Yes, we need to solve for A. So between 0 and 3, so between 0 and 3, that's directly cut in half, so that's going to be a -0.5. And that's going to be pi, so this is going to be a pi minus 0.5. Sorry about that. Okay, thank you for catching that.
Wait, am I going to get a point though? I keep saying f
Why
of
is
x.
it? Isn't it just -1 because you're not including
He
0.5
said it
at
needs
the
to
end?
be a different way.
So from here
Oh,
to
okay.
here, yeah.
I get it. Okay.
Like, I don't know.
Relative maximum. So relative maximum, this is going to be where g prime of x goes from a positive to a negative. So g prime of x is the same thing as f of x, which means we're looking for a height where does the height go from a positive to a negative? It goes from a positive to a negative there. And that's it. Yeah, so we say at x equals 2, and our rationale is because we need to give the definition where we say g prime of x goes from a positive is 0, and it goes to g prime of x becomes a negative.
Mr. Snow,
Yes.
what if I said x equals 2 because g prime goes from a positive to a negative?
That's perfect, yep.
Like,
She doesn't want to mess with her
I don't like
alligators.
alligators.
That's fine, yeah.
So you don't have to use the fancy mumbo jumbo that sometimes
You don't have to if you like writing out the words.
Is it okay if I put in 2 for the x's?
literally.
2 for the x's? Yeah, that's fine.
Oh.
Like g prime of 2 is greater.
You don't know
Yeah.
what I was doing.
You're gonna get your hair dry.
All right, and part C, write an equation, line tangent. Line tangent means y minus something is equal to the slope times x minus the x coordinate. All right, so x coordinate is going to be 3. I should write a 3 better there. And then what goes in here, girls?
-1.
So, well, what value?
G prime of
Oh.
G prime of 3. Yeah, eventually we'll get the answer. And what goes in here?
G of 3.
G of 3. Oh, look, we calculated G of 3 all the way back
I
here.
love when that happens.
So pi minus 0.5, so we can write that in here. This is going to be pi minus
then you would have a second.
0.5. And make sure you have parentheses, because if you don't have parentheses, I'm not giving you the point. Or if you distribute the negative. All right, and then G prime of 3. G prime is the same thing as F, so we're really saying that this is, where is F of 3? Evaluate the height at 3. Height at 3 is -1.
Put your hand
So
up.
-1, and you're done.
Just don't care.
All right, and part D, find the x coordinate of the inflection point. So, what is the definition of an inflection point in terms of G?
Double prime.
G double prime equals 0.
G double, well, I did a capital G. G double prime, yeah, not equal 0, it's a sign change.
Oh,
That means we know that G prime of x is the same thing as f of x. We've already defined that. That means G double prime of x is
F prime.
f prime of x. So what we're really saying is we're looking for what on our graph?
Slope change.
Slope change, exactly. Slope sign change. So slope sign change. Oh, I can't speak. Positive to a negative, therefore that is an inflection point. Goes from a negative to a negative, so that's not an inflection point. Negative to a positive, so a sign change there, and it stays positive. So we have 2 inflection points at x equals 0 and at x equals 3.
so even if it is a sharp corner, it still counts as an IP point?
Yep. Because it did a sign change. The slope sign changed. Yeah.
Wait, so does it make sense if I just say like because G double prime changes sign? Like is that enough?
And
Yeah,
what if
G-
I say f prime
Ooh, I
of x changes sign? You think I would get it wrong?
You need to say G prime. Because if they give you G, you need to have G in your answer. It's okay to get it wrong now. This is just the self-check. Now you know for the pretest what to put. You need to put G double prime sign change. Perfect. Let's go on to self-check 10.3. Right, self-check 10.3. Here we go kind of fast because we're running low on time. On any intervals is f increasing. Definition of f increasing is where f prime is greater than 0. F prime, this is the graph of f prime, so height greater than 0. It's just this part right there. So we say f is increasing on -3 to -2. And our reasoning is because this thing, because f prime is greater than 0. On to number B, or letter B. So, inflection point. Definition of inflection point is where f double prime sign change. Sign change. That means we're looking for the slope sign change. So, slope is negative and positive, so it changes there. Slope is positive to negative, changes there. So at x equals, not -2, x equals 0 and 2, and it's because f double prime sign change.
Woo!
IP is at, I guess I should put in there. And on to part C. Find the equation, line tangent, so it's going to be y minus something is equal to the slope times x minus the x coordinate. All right, shoving these in here really quick, we have an x and a y right here. So the x is 0, the y is 3. And to find the slope, we have a graph of the slope, so this needs to be f prime of 0 right here. F prime of 0 means the height at 0. Height of 0 is -2. So this is a -2, done with part C. On to part D. We need to find f of -3. This is going to be start plus change equals end. So f of -3, we need to do start plus change equals end. The start information is right here. start.
Oh,
So the time starts at 0, the position starts at 3. So this is going to be 3 plus the integral between 0 and -3. Again, I started at 0 because the start time was 0 right here. Therefore, I'm going to go -3 of f prime of x dx. That's going to change into the function 3 minus the integral between -3 and 0 of f prime of x dx. I just switched the limits and made this a negative. And between -3 and 0, what is that going to look like? -3 and 0. So I have, what is this area right here? 1/2 or 0.5, and this is going to be an area of -2. I add those up and I get -1 1/2, or -1.5. So this is going to be equal to 3 minus 1.5, and the answer here is 4.5. Be careful with these double negatives. You should have double negatives there. Finally, f of 4, a little bit easier. This is going to be 3 plus the integral between 0 and 4 of f prime of x dx. And that's going to turn into, I still have my initial condition, 3 plus, and between 0 and 4. What does that look like? Well, this is a shape where this is 2 pi. This entire rectangle is 8 because it's a 2 by 4. So this entire area here is 8 minus a 2 pi. 2 pi for that area. So I can just say this is going to be 3 plus 8 minus 2 pi. I could keep parentheses around here, but it doesn't matter. I'm distributing a positive. And our final answer is going to be 11 minus 2 pi.
Wouldn't it be -8 minus 2 pi?
-8 minus 2. Why did you have a negative?
Put it under the...
Oh, you got it. Yeah, that's an extra credit point. So this, all of this should be a negative because it's below the extra. Yeah. So that means my answer key that I gave Joy was wrong as well. So that means I can change all of this. So if I subtract, you should get a -5 plus 2 pi.
Nice.
Yeah, good catch.
Add, wait, no, never mind.
Yep. All right, homework is self-check 10.4. There will be a video solution online by the end of today. And on to self-check 10.4. So we have this function, and this is one that we can use a calculator on. This function is f prime, and it also gives us f prime here. So it gives us the graph of f prime, and it gives us the function of f prime. So let's go ahead and do this. So where is it concave up, concave down, or neither? What is it doing on 1.7 and 1.9? Okay, so 1.5 is right about there, and 2 is there. So it's really asking between about this interval right there. What's happening? And what we're doing is concave. So what is concavity? So concave up, that's where f double prime is greater than 0, and concave, I guess our function is f concave up and f concave down. And it's concave down where the second derivative is less than 0. Alright, so we need to find f double prime. It's already given us f prime, so f double prime on this graph is going to be not height, but slope. Alright, so what is the slope doing? Slope is negative here. So because slope is negative, it's concave down, and that's what we need to say. So f prime is concave down on the interval 1.7 to 1.9. And you need to explain your reasoning. So our reasoning is because f double prime is less than 0 on that interval. Perfect. On to part B. So now on that same interval, or on a different interval, 0 to 3, find the absolute maximum. Okay, so our last self-checks we've been finding relative maximum, relative minimum. So absolute maximum, now we're making a table. All right, so we have an x, and we need to have our start point, our end point. So start is 0, our end point is 3, and we'll make our table here. So this is going to be start plus change, and that will be equal to the end. I'll write that in a sec. All right, what is the starting value? So over here, if we see here, our starting value is 0 for a time and 5 for the value. So 5 is going to be the number in our table. 0 is going to be the part of our integral. So what does that look like? So all of these are going to be 5, 5, and however many critical values that I still need to find. And then this is going to be plus the integral from 0 to that x coordinate 3 of f prime of x dx. All right, so now we need to find critical values, and this is where we need a calculator. All Alright, so we have our calculator, and we need to go to the last slide. So I have my equation. I need to enter that equation into my y equals. So this is the derivative of f prime. It's going to be second natural log, so that's e to the power of negative x divided by 4 in the parentheses. That's going to be multiplied by sine of x squared. Alright, so we can get rid of that. I mean, we could graph it, but we don't need to. So we'll get out of that. And we need to find now, come back here. We need to find critical values. So I think actually we do need to graph it. I apologize. We do need to graph it. And the interval is between 0 and 3 to get the same graph. So if we do window, we want to go from 0 to 3, and we hit zoom 0 to get the same function. So this graph should match the graph on our calculator if it goes ahead and does that. Meanwhile, what we're looking for is critical values. We're looking for that value and that value, where it crosses the x-axis. What is that exact coordinate? That is the critical value. Both those points are critical values, but do we need both of them? Because remember, we're looking for maximum. So maximum means where we have positive area. We don't really need this critical value because we have a bunch of negative area after this positive area, but if you want to throw it in there, it's fine. It just means more work for you. All right, so yes, we have the same exact graph. So I need to find that 0, so I'm going to go second trace, looking for 0, so I hit 2. And left boundary, we can say 1, right boundary 2, middle 1.5, somewhere in between those 2 points. And we get our 0 at 1.772, so 1.772. And just in case you want to find this one, it's impossible for it to be an absolute maximum, but I can do it anyway if you'd like. So second trace 2, and left boundary, we can say we're looking for this point, so between 2 and 3, so 2 to 3, and any point in between 2.5 is fine. And we get that point, which is 2.507. 2.507. And again, both of those will have starting values of 5. This one is not going to have any change because it's from 0 to 0. This one is going to be plus the integral from 0 to 1.772. This is going to be plus the integral from 0 to 2.507. All of these are f prime of x dx. F prime of x dx. And now we need to find these. So I could find it graphically by doing second trace 7, and then I could go from 0 to 1.772. So that's the way to do it graphically, and then the next 2 calculations I'm going to do it without a graph. So graphically it'll say, yep, that's the area, and so we have that number 0.679, so this is going to be equal to 5 plus that, so 5.679. How to do this without the graph though, so let's get out of that. If I do 5 plus, so I already have the 5 included, math 9, the integral, and it's going to be the integral of var's right, enter of that y1 function with respect to x from 0 to, okay, I hid the 2, it's to 2.507, to 2.507. And that is going to be, it's 5 point something I would imagine, yeah, 5.407, so 5.407, or I guess if I'm rounding correctly, 5.408. And this makes sense, so it is less than this point, and that makes sense with the graph that we had. We have a bunch of negative area right here, so it should be smaller than the value that we found right there. All right, so it matches intuition. We didn't need to find that line at all. And finally, we need to do this line, so it's quicker to do it this way. I do second enter, and instead of 2.507, I delete a bunch of those points, delete, and change that to a 3. And when I do that, I get probably 5 point something, yeah, 5.579. 579. All right, absolute maximum coming back here. It's the biggest one. That's the maximum, and it's asking for a value of x. So I'm just going to put both of them in the answer so I don't make a mistake. By the way, I should complete my table up here, so I don't make a mistake. Absolute max is 5.679, and it's at x is equal to 1.772. Perfect. And on to part C. Write an equation for the line tangent. Line tangent means we're doing y minus some number there. I'm making it big because I feel like it's going to be a decimal. It's going to be equal to some number there, maybe also a decimal, times x minus, well, I know the x coordinate is small, so I'll just leave that as a box. I could just write 2 right away. All right, what goes in these boxes? This is a 2. This is going to be f prime. It is f, right? What was our function? F, yeah, so this is going to be f prime of 2, and this is going to be f of 2, the y coordinate at 2. for that box. All right, what do we already have? We know that this is going to be 2. Fill that in. F of 2 is going to be a little bit difficult to find. We basically have to do this table again, start plus change equals end. I have that on the calculator already, so I'm just going to do second enter, and instead of a 3 there, I'm going to do a 2 there. Mathematically, what I'm saying is I'm doing f of 2 is equal to my start, 5, plus the change, integral between 0 and 2 of f prime of x dx, and that is equal to, as the calculator says, 5.623. And I can go ahead and fill that into my table. That is going to be 5.623. All right, we need to find f prime of 2, and hey, we have a graph over here. If I hit trace, I can just enter 5.623 here, 5.623, and it tells me, oh, what did I do? Go to x equals 5.62. Oh, you don't want to put 5.623. You want to put 2 in there. So let's clear that. We want to put 2 because f prime of 2, and it says at the value of 2, we have negative 0.459. So this is going to be a negative 0.459. But Mr. Sindel, can't you do that without a graph? You are correct. You could have gone vars right, enter, y1 of 2, and it will spit out the same number, more or less, negative 0.459, same number. And that is the line tangent. And that concludes Self Check 10.4.